In this video, we'll complete the code for the crowdfunding contract. We'll first write the code for the transition get funds and these two procedures associated with it. The get funds transition allows the owner of the contract to get funds to his account, given two conditions are met. First, the current block number should be greater than or equal to max block. Second, the balance of the contract should also be greater than equal to goal. And these two are immutable variables. Let's define a check for these two conditions in the library part of the contract. We'll create a function getFundsAllowed. This function takes in 4 arguments. The first argument is the current block, which is of type block number. The second argument is the max block, which is again of type block number. The third argument is balance, which is of type an unsigned integer. And the fourth and the final argument is goal, which is again an unsigned integer. Now let's take our first condition, which is that the current block should be greater than or equal to the max block. So we'll define one variable in time, and we'll actually use our function that is just above this function, which is BLK-LEQ, which is block less than equal to. And we pass in 2 arguments, current block and max block. This will tell us whether current block is less than or equal to max block, and it will store the value in the in-time variable. Now what we need to do is we need to do the negation of this value to know whether current block is greater than or equal to max block. So we'll define another variable. Let's call it deadline passed. And we'll apply the logical negation operator, which is this. And we pass in time. And this will do the logical negation of in time and store that value in deadline passed. So if in time was true, deadline passed would be false. Now let's check for our second condition, which is that the balance should be greater than or equal to goal. So we'll define a variable target not reached. And we'll use the built-in operator, built-in less than, and we'll pass in balance and goal. Now this will check whether balance is less than or equal to goal, but we need to do the opposite. We need to find whether balance is greater than or equal to goal. So let's create another variable that stores that value. So let's call it target reached. And we'll again do the negation operator. Now these two variables actually have the value whether the deadline was passed and whether the target was reached. Now both of these need to be true for the owner to get his funds when he calls the get funds transition. So we'll do a logical AND operator. And we'll pass these two variables. Okay, so now this function is complete. Let's move back to our transition. Inside this transition, we first need to check whether the person calling this transition is he the owner or not. So we'll use this equality operator and we'll check the owner variable with the sender variable, and owner, again, it fetches from the immutable variable owner, and underscore sender is actually an implicit variable which gives us the address of the person who is calling this transition. Now we use the match statement to handle 2 scenarios, whether isOwner is true or false. If isOwner is false, what we'll do is we'll call getFundsFailure, and we'll pass in an error code which is not owner code. Now let's handle the case when isOwner is true. So first we get the current block number and store it in this variable BLK. Then we get the balance of the contract. And finally, we'll call getFundsAllowed, which we declared above in the library part of the contract, to check whether the owner can retrieve the funds or not. And we'll pass in 4 arguments to this. So first one is BLK, which is the block number, current block number. Then we pass in max block, which is an immutable variable. Then we pass in the balance, which is BAL. And then we pass in the goal. And let's store this value that is returned by this function in another variable, which is allowed. Forgot to add a semicolon here. After this is called, we'll get either allowed as true or false, and we'll handle those 2 conditions again using the match statement. So for the false condition, again, what we'll do is we'll call getFundsFailure and pass in the error code cannot get funds, which is mentioned here. And for the true condition, we'll simply call perform get funds, which is this procedure here. Now let's just end these 2 match statements. So this is the end for the inner match statement, and then we have another end for the outer match statement. Let's complete these 2 procedures associated with the get funds transition. First, we'll complete the code for the getFundsFailure procedure. This procedure essentially will emit an event with the event name getFundsFailure. So here I'm creating the event object. Event name is getFundsFailure. Caller is the sender. Amount is the amount. And code is the error code that is passed to this as the argument. And let's finally emit this event. Remember that we had this funded mutable variable up here, and this was set as false. When the contract owner finally retrieves the funds using the getFunds transition, this funded variable is set to true. So we'll handle that case here in perform getFunds procedure. Let's define a variable TT as true, and we'll set funded as TT, which means funded is true. And as you can see, this is the syntax for updating a mutable variable. And what this procedure would do, essentially, it will transfer the balance of the contract to the owner of the contract, and we'll use messages for this. So as is compulsory with messages, it needs to have a tag. So we'll define a tag here. Let's just keep the tag as empty. Then it needs to have a recipient. So recipient here is the owner. Then we'll define the amount. Amount refers to the amount that is going to be sent to the recipient. So that will be BAL here. That's essentially the balance of the contract. And then we'll also pass in one code which is associated with that the funds were withdrawn correctly, and that is got funds code. And if we go up, we see that it's defined here. And as we have now defined this message object, let's pass this to one message function. And in order to emit this message, we'll use the send keyword and we'll pass in this messages. So this completes our procedure perform get funds. Also, as you would have seen, we have used this one message function, which is quite common in many Scilla contracts. And let's actually define this function in this contract as well. The one message function essentially takes in one argument, which is the message, and it returns a list with that message added to the list. So here it takes this one argument, let's call it message, and the data type is a message. And we first define an empty list. And this list contains items of type message. And then finally, this function returns this list with the message added to it. So we use this syntax for doing this. Cons message message and nil message. Now let's move to our final transition, which is the Claimback Transition and the procedures associated with it. The Claimback Transition allows a donor of the crowdfunding contract to claim back his funds if the goal of the contract is not reached till the maximum block number. As we did with the getFunds transition, we'll write a library function that checks for the conditions when a claimback is allowed. Let's name this function ClaimbackAllowed. This function will take in 3 arguments. The first one is balance, which is of type unsigned integer. The second one is goal, which is again an unsigned integer. And finally, it takes one more argument, which is already funded, and that is of type bool. Now what essentially is happening here is we'll check whether the balance is less than goal, and already funded refers to whether the campaign was successful and the owner of the contract was able to withdraw the funds. As you remember here, when this procedure was called, which is perform get funds, we set the value of this mutable variable funded to true. So here what we'll do is we'll pass the value of funded to this function, and if it's true, that means that the campaign was successful and the person shouldn't be able to withdraw the funds. So let's store our first check, target not reached, and we'll use the built-in operator to do this check, and we'll use built-in less than balance goal, which is our balance is less than goal. And for our second check, we'll define a variable not already funded, which is basically the logical negation of already funded. And essentially what not already funded means is that the contract was not funded and the owner was not able to withdraw funds from the contract. And finally, we'll do a logical AND of these 2 conditions. Essentially what this AND operator does is it checks whether balance is less than goal and whether funded was false. If both of them are true, only then the claimback is allowed. Okay, so now let's come to our transition, claimback, and we'll first get the current block number and store it in this variable blk. Now we need to check whether max block is less than blk. So we'll do this check and store this in this variable after deadline, and we'll use the built-in operator blt, and we'll pass max block and blk, which are both of type block number, and essentially it checks that the current block is actually if it's greater than max block, and if it's greater than max block, after deadline will actually be true in this scenario. What this does is it checks whether max block is less than blk, which means the current block is greater than max block, and we'll handle what happens if after deadline is true or false using the match condition. So match after deadline with, and let's also end this match so that I don't forget. If this is false, which means that max block is not less than blk, we'll call claimback failure procedure, and we'll pass in too early code. If after deadline is true, we'll do this. We'll first fetch the balance of the contract. Then we'll fetch the value of the funded variable, which is a mutable variable that was defined above. And then we'll actually call the check that we defined in the library part of the contract, which is ClaimbackAllowed. So ClaimbackAllowed, and we pass in these 3 variables: balance, goal, and if. Let's store the value that this function returns in the variable allowed. Now allowed will again be a boolean, so let's handle the cases when it's either false or true. If it's false, we'll call claimback failure again with another error code, which is cannot reclaim code. If it's true, then we'll do this. So we'll first check the value that the person donated by looking at our backers map, and in the backers map, we'll pass the key as the sender address. So we'll match here res, the value that the person had donated to the crowdfunding contract, that gets stored in res variable here. And what we'll do is we'll match res with none. So if the person didn't donate anything, then this part of the contract code will run. So the person didn't actually donate anything, so we'll call claimback failure again. And we'll pass in cannot reclaim code. If the person did actually donate something, then we'll come to this part of the match statement, which is associated with sum, and we'll store the value of res in this variable v, which represents the value that the person donated. And we'll call perform claimback procedure, and we'll pass in this variable v. And now let's end these two inner matches. So here I end this match, and then we also need to end this match, and we are done. So our transition claimback is done. Now let's finish writing procedure claimback failure and perform claimback. Coming to procedure claimback failure, this will have an event object, and the event name will be claimback failure. And the caller here is the sender, and amount is _amount, and code is the error code that is passed to this procedure. After defining this event object, let's emit this object. Now coming to our procedure perform claimback, we first need to delete the entry of the sender from our backers map. This is done so that the sender is not able to call this transition claimback again and again, and he shouldn't be able to call this again and again and retrieve his funds again and again. So we'll delete his entry from this map, and in order to send the amount to the sender, we'll use messages. So let's define a message here. The recipient is the sender, and the amount will be the amount that we'll take from this argument, and the code will be reclaimed code. I added this by mistake. I need to have an equality operator, and then what we'll do is we'll create this messages variable, and we'll call our one message function, and we'll pass the message that we created above to this function, and we'll finally send this message. So this completes our procedure perform claimback, and with it we complete the code for the whole contract. In the next video, we'll actually deploy this contract and play around with it and explore some edge cases around this contract. So see you soon.